There are many, many different flavors of GPS devices out there. They could be handheld ones, they could be apps that are on your phone, and we'll talk about them in a second. But regardless of what you use, there are a couple basic things you need to know, and it is your responsibility to know how to use your equipment. The first thing you need to know is how to change your coordinate system and format. This is something you'll need to demonstrate to us over the course of MRC Weekend. You'll also need to know how to change your data. Another thing you'll need to demonstrate to us. You'll need to know how to find your current coordinates when you're looking at your GPS screen, and how to create and name a waypoint. You'll also need to know how to start, clear, record, save, do basically anything with a track. And then lastly, you'll need to know how to give your track to somebody else. This could be over email, it could be directly uploading it to a computer, but you'll need to know for your specific GPS device how to do that. And if you need to upload it directly to a computer, it's your responsibility to make sure you have a USB to whatever flavor of connector goes on your GPS device cable. Now, let's talk a little bit about datums. Essentially, datums represent a way to put the coordinate system into actual places on the globe, reference points that we use to overlay coordinate systems. There are a couple main datums that you'll probably see. The earliest one is NAD 27. It was the first well-used North American datum, and it was created in 1927. It was good for the time, but technology has improved significantly since then that allow us to be a lot more accurate. And NAD 27, while it might exist on very old maps, is not used currently on modern maps. Instead, you'll probably see either NAD 83 or WGS 84. Both of these are very similar. NAD 83 was created as an update to NAD 27 in the year 1983, as the two digits on the end kind of indicate. And it used things like satellite geodesy and remote sensing to better approximate the shape of the Earth. WGS 84 was created 1 year later, and it represents a global system. It's very, very, very similar to NAD 83, and they're often used interchangeably. So on some GPS devices, you'll see one or the other, but not both. Now, NAD 83 and WGS 84 differ substantially by NAD 27, often by tens of meters, but it depends on your location. So for example, the same set of coordinates represented in the real world would be 95 meters apart in Seattle between NAD 83 and NAD 27, and in Miami, roughly 50 meters. It is vitally important that before you go out into the field or before you communicate coordinate systems to anybody, you make sure that your GPS device is set to the correct datum based on the map that you are using. If you're given an NAD 27 map, it needs to be set in NAD 27. If you're given a US National Grid map, it needs to be set in NAD 83, which is standardized on US National Grid is standardized on NAD 83, and so it has to be set for that. This information should be available to you at the on the whiteboard in the staging area. If it's not, and all that's up there are coordinates, plug those coordinates into your GPS device and see if it gives you the location that you're at. If it doesn't, this might mean your datum is off.
This is important because oftentimes on drills, we might practice switching between NAD 27, NAD 83, WGS 84, so that we know how to do it when we encounter a map, an old map that, say, somebody out there was using to find mines or whatever it is. And then we go home, and then the next day we have a search and it's still set to NAD 27. And that would put us in a totally different location for the coordinates we're given than if we had the correct datum, NAD 83, with the map that we're using that day. So it's important to always check, as Jeff said, the whiteboard at staging and to know how to change your datum on your GPS device.
There are a couple of other things that you're going to need to be familiar with on your GPS device. The first is the waypoint button. Every GPS device should have a way to create a waypoint. Oftentimes, it's a dedicated button. Sometimes you have to go into a different menu, but you need to know how you create that. On most dedicated GPS devices, you'll have a button. And when you press that button, it will drop a waypoint at your current location. The other thing you need to know, in your settings on your GPS device, frequently, it gives you the option to choose north up or heading up. North up would be kind of like a map, where north is always at the top of your map. Heading up would be similar to a GPS device that you use for driving, where the azimuth at the top of the device changes depending on the direction that you're facing. Do everyone a favor, and when you're out in the field for New Jersey Search and Rescue, use north up. It's much easier to use when hiking, and it's much easier to help orient yourself with a map. Many GPS devices also involve more than just GPS satellites. For example, GLONASS, which is a Russian positioning system similar to the GPS system that we use in the US. Turning the setting on can give you better accuracy or a quicker fix. Turning it off will save battery life. So it's kind of a trade-off. Usually the battery consumption on this is minimal. So unless you're running very low on batteries, it makes sense to turn this on if you have the option to use it. EGNOS is similar to GLONASS, but it's European and not Russian. In addition to both of those, which are satellite systems, there's something called the Wide Area Augmentation System. And this, just like a GPS device communicates with satellites, communicates with stations on the ground to give you a more accurate GPS reading. Turning this on will increase accuracy, but again, come at the cost of battery life. Also, many GPS devices have a routing method. This handles how a GPS will produce a route to a destination. For example, if you enter headquarters in your GPS as you're driving to a drill, the route that it takes you on roads is the same type of route this could create. Most GPS devices do not have the ability to route along trails. And because of that, for off-road travel, you should have this set to direct routing, which will take you on the shortest route, usually a line between 2 points. Otherwise, it may try to route you along a road, it might not realize that there are trails that are there, and you might end up taking a much longer route or an incorrect route to get to a location.